section in chapter 11 is about composite figures. And an example of a composite figure is if I were to take many geometric figures, three-dimensional figures, and stack them one on top of the other or next to each other. Here's an example of a nautical prism that has three parts to it. It has three solids. The very bottom base is a hexagonal prism. And then the second middle part is comprised of another hexagonal prism, and then the top is a hexagonal pyramid. So we're going to be taking many figures and putting them together. So let's take a look at number 2. In this case, instead of putting things together, we're actually going to take things apart. So the question is, what is the volume of the solid? Which means if I were to take this, and I can think of it as a bead. Sometimes when you string beads together, there's that little opening down the middle to put the wire or the string through. And so this is a rectangular prism that has a smaller rectangular prism that's been taken out of the middle. So to find the volume of this whole solid, I'm going to find the volume of the large prism and I'm going to subtract the volume of the smaller prism. So I need to go back to my volume formulas. Get back to volumes. Let's erase what we have here. We just put a whole bunch of stuff here. All right, and we're taking a look now at the formula for a rectangular prism. So here are our prisms. And once again, capital B is the whole entire area of the base, and H is the height of the prism. So we're going to find the volume of the large figure, and then we're going to subtract the volume of the smaller figure. Okay, so let's take a look at the larger. The larger has a base that is 12 by 4. 12 times 4 is 48. So the area of the base is 48, and the height is 8. Now, looking at the smaller prism inside, it looks like this length right here is 3. This length right here is 2.5. So the area of the base is 3 times 2.5, or let's just try that again. I put in 13. 7.5. And the height is the same height as the prism that it's enclosed in. So the height, again, is 8. All right, so to find the volume, we're going to multiply 48 times 8. And then we're going to subtract 7.5 times 8. And so that entire volume is 324. And that's cubic feet per volume. Right, so here's an example like we were talking about before where we're stacking one solid on top of another solid. So the best way to describe this is we have half of a sphere. Let's try this again. Okay. There we go. All right, so this is half of a sphere. That's setting on top of a cylinder. And we're going to switch from volume to surface area. So let's take a look at our formula sheet for surface area, and I'm looking for the volume of a sphere and the volume of a cylinder. Okay, volume of a sphere and the volume of a cylinder. All right, so the sphere is 4 pi r squared. But what I have to remember, it's only half of a sphere, so I'm going to divide that formula by 2. Not the entire sphere, it's only half. The volume of the cylinder is 2 pi r squared plus, we're not doing volume. Let's go back in. Let's change this to surface area. Done that twice today. All right, surface area and surface area. All right, so right formula, wrong name. So the surface area formula for a cylinder is 2 pi r squared plus 2 pi r h. Now, here's what we have to remember. If we were painting this whole entire figure, we would not be painting this circle inside here. And that figure on the inside is the top of the cylinder. Now, the cylinder has a circle at the top, and it has a circle at the bottom. Now, we are going to paint this exposed area that's on the bottom of this figure, but we are not going to paint the surface on the inside of this figure. So instead of having 2 pi r squareds or 2 circles, we're only going to paint 1. All right, so we just have to remember when we stack things on top of one another, we don't paint the part that's on the inside of the figure, we're just painting those parts that are exposed. That's a really important word right there, is exposed. All right, so I have 2 formulas that I've modified. Instead of a whole entire sphere, I only have half a sphere. And instead of having a whole cylinder, I have a cylinder minus one of the circles on the top. All right, so let's go ahead and put in our values. We have 4 times 3.14, and the radius is 10, and then we're going to divide that in half. And then for the surface area of our cylinder, we have 1 pi r squared plus 2 times pi times the radius, and the height is 7. and then we're going to divide that by 2. And we get a surface area of 628 for the half sphere. All right, and then we're going to find the surface area of the bottom cylinder. And then to find the total surface area, we're going to take those two values and add them together. So we already have 756.6 in the calculator. We're going to add 628 to that. And we have a total surface area of 1,381.6.